Today we will read about simple connections from structural design 2. We are studying about different types of steel structure or about the design of steel structure in structural design 2. And the examples of steel structures are like roof of railway stations, auditoriums, toll gates, etc. I am telling a simple example which we are using in our day-to-day life. That is a grill of window. That is one example of steel structure, and we are making steel structure by connecting more than one members of different shapes and sizes. Generally, we are using rolled sections for making steel structures. Rolled sections like I section, T section, channel section, and angle section. There are so many other sections which we are using for steel structure. So these are the images, some images of steel structure. Here, see in this image, here the man is holding, and this is another image. So let's start simple connection. And what are the types of simple connection? And what are the methods by which we are connecting the members in case of steel structure? Let us start the first slide. So the following are the common types of connections used for steel works. So there are four types of connections. One is riveted connection, another one is bolted connection, third one is pinned connection, and welded connection. So today we will cover riveted connection, what is rivet, what is riveting, and what are the types of rivet we are using, and what are the different types according to the shape of the head, according to the place used. Today we will study or cover. So let's start riveted connection. So riveting is a method of joining together structural steel components by inserting ductile metal pins called rivets into the holes of the components to be connected. Means if you are connecting two members, this is one member and this is another member. So the two members must be overlapped with each other, and in the overlapping portion we have to make a hole. The hole diameter must be small d, that is the gross diameter, and into that hole we are inserting a rivet, and the rivet diameter must be 5, which must be less than the gross diameter. The rivet diameter 5 is named as nominal diameter, and the gross diameter small d is named as gross diameter. Then there are, in a rivet there are two parts, one is shank, another one is head. The body part is known as head, or the body part is known as shank, and the uppermost part is known as head. A shank of given length and diameter, and second one a head known as manufactured head. So in riveted connection, according to the place used, there are three types of rivets. One is hot driven rivet, another one is hot driven shop rivet, another one is cold driven rivet. Hot driven field rivet, hot driven shop rivet, and cold driven rivet. So hot driven and cold driven. Hot driven, cold driven, what is the difference? Hot driven means before insertion of the rivet, we are heating the rivet, that is known as hot driven rivet. And if you are inserting the rivet within the room temperature, that is known as cold driven rivet. That is the only difference between hot driven rivet and cold driven rivet. Next is field rivet and shop rivet. Field rivet means we are using the rivet in the field, that's why that is named as field rivet. And if you are using the rivet within the fabrication or within the shop, then that is known as shop rivet. So let us see the definition. So hot driven rivet, when the rivets are heated before inserting, they are known as hot driven field rivet, and depending upon the place, they are selected as field rivet or shop rivet. So hot driven field rivets are used in field. Hot driven shop rivets are used in field. And next is hot driven shop rivet. when the rivets are heated before inserting and used in saw is known as hot driven saw rivet. And the last one is cold driven rivet. When the rivet is driven at room temperature is known as cold driven rivet. So there are three types of rivets: hot driven saw rivet, hot driven field rivet and cold driven rivet. Only difference is when we are heating before insertion, that is hot driven, and when we are using in field, that is field rivet, and when we are using within the room temperature, that is cold driven, and when we are using within the fabrication or soft, that is soft rivet. Okay. So next division is based on the shape of the head. There are four types of rivets according to the shape of the head. First one is snap head rivet, another one is pan head rivet, third one is flat countersunk rivet, and fourth one is round countersunk rivet. So first, snap head rivet. This division only based on the shape of the head of the rivet. So this is snap head rivet. See here in this rivet, one body part is there and the upper part is named as head and the body part is named as shank. And the head is like a half circle. That's why that is named as snap head rivet. If the shape of the head is like a half circle or like this, then that is named as snap head rivet. Here round countersunk, that is the next one. Here also one shank is there and one head is there. If the shape of the head is like this, then that is named as round countersunk rivet. Next is flat countersunk rivet. If the shape of the head is like this, then that is known as flat countersunk rivet. Here also one shank is there and one head is there. Then the last one, that is pan head rivet. In case of pan head rivet, the shape of the head is like this. See, here is also one head and one shank. Okay. So according to the shape of the head, these are the various types of rivets. So these are the line diagrams. If this question comes in the exam, then we will draw these figures, these line diagrams. This is very easy to draw. There is snap head, pan head, flat countersunk, round countersunk. These are the line diagrams of different types of rivets according to the shape of the head. See this figure. This is the figure of total rivet joint. This is the figure of total rivet joint. Here two members are connected by overlapping with each other. This is one member and this is another member. By this process, two members are connected. This is one and this is another member. Two members are connected by overlapping with each other. This is the side view. Here, two members are connected by overlapping with each other. Then in the overlapping portion, first we have to make a hole and the hole diameter must be small d, that is the gross diameter of rivet. Next, you have to insert and rivet. It may be your flat countersunk, it may be pan, it may be snap, it may be round countersunk. You have to insert a rivet within that hole and the rivet diameter must be less than the gross diameter and the rivet diameter is named as nominal diameter or phi. And the hole diameter is named as small d or gross diameter of rivet. Okay. So then we have to insert the rivet into the hole. Then you have to apply pressure or force at the next end to make the rivet connection fixed. Okay. Then here another term is there, that is greave. Another technical term is there, that is greave. What is greave? So if you are connecting two members, this is one member and this is another member. If you are connecting two members, the total thickness, if you are adding the first member thickness and second member thickness, the total thickness is known as greave. The total thickness, the first member thickness with the second member thickness, the total thickness is known as greave of the member. Okay. And length is the total shank length of the rivet or body length of the rivet. There are two parts in a rivet. One is shank, another one is head. So the total length of the shank is known as length. Okay. So this is the figure of rivet joint. So nowadays we are not using rivet joint. See, these are different steps of riveted connection. So first step, see, here some holes are there, two members are there also. This is one member and this is another member. Some holes are there. First we have to make holes. Then in the second stage, we have to insert the rivet into that hole. This figure shows hot driven rivet because it is heated before insertion. That's why the color is red. Okay. So third step, here the rivet is inserted into the hole. Then after that, we are applying external force. External force we can apply machine. We can apply manually by using hammers. Here in this figure, we are using a machine for applying external force to press the upper end. See, here in this figure, the rivet is pressed, and this is the final figure of riveting. This is the final figure of riveting. There is another figure. See, these are rivetings. So many types of rivetings are there. See. So by this process, riveting, we are connecting different members. There are more than one members here connected. So nowadays we are not using riveting. There are advantages of riveting. Riveting is a rigid connection and it also gives more strength. But there are so many disadvantages. That's why we are not using riveting. What are the disadvantages? Let us discuss. So first, nowadays riveting is no longer used in engineering structures because of labor cost associated with large riveting screws. In case of riveting, large riveting screws are used, and also so many labor cost is there. That's why we are avoiding riveted connection. And second is high noise pollution. During riveting process, it may be manual or by using machine. There is high noise pollution. That's why we are not using riveting. And high structural weight. If you are making a structure by using riveting process, then the structure becomes heavy weight. That's why also we are not using riveting nowadays. These are the drawbacks. And in simple connection, there are so many technical terms we have to cover before designing. We have to cover so many technical terms. Let us start the technical term. The following definitions are used for riveting or bolted connections. These are the technical terms which we will cover during designing. First is the shank of the rivet before riveting is called the nominal diameter, which we have already discussed in third or fourth slide. Okay. So the nominal diameter is the diameter of the shank or diameter of the body. Next is effective diameter or gross diameter. Effective diameter or gross diameter. The effective or gross diameter of a rivet is equal to the diameter of the hole. Here I want to mention one another line. So nominal diameter equals to effective diameter equals or gross diameter and nominal diameter. So small d equals to 5 plus 1.5 when the diameter of the rivet is less than 25. The diameter of the rivet is less than 25 millimeter. So there is a formula to calculate gross diameter. Gross diameter equals to nominal diameter plus 1.5 when the diameter of rivet is less than 25 millimeter, and gross diameter equals to nominal diameter plus 2.5 when diameter is greater than 25 millimeter. Means the diameter of the rivet is greater than 25 millimeter. This is the first step of design. Okay, this is the first step of design, and this procedure we have to follow in every question. In every design question, we have to follow this step. This is the first step. And this formula we have derived from the code, that is IS 800-2007, which is used for design of steel structure. And the formula is gross diameter equals to nominal diameter plus 1.5 when the diameter of rivet is less than 25 millimeter, and gross diameter equals to nominal diameter plus 2.5 when the diameter of the rivet is greater than 25 millimeter. So you have to remember these two formulas for calculation of first step 1. Next technical term, that is gross area. So when we are calculating the area by using the gross diameter, then that is known as gross area. Similarly, when you are using the nominal diameter for calculating area, then that is known as nominal diameter. So next is pitch. Pitch, that is very important. Pitch, the distance between centers of any two adjacent rivets is called the pitch. This is a very important definition. So let us see an image so that we will understand clearly what is pitch. See this image. So here one dotted line is at the mid portion and two solid lines are there, and two forces are acting at the two ends. Here one force at the left side and another force at the right side. Yes, at the mid portion there is a solid line, and pitch, edge distance, end distance, gauge, different technical terms are there. So there are four types of connection, but within the connection there are different types of joints. So like rivet connection is divided into two types of joints. What are the different types of joints? First is lap joint, another one is board joint. What is lap joint? So if you are connecting the member by overlapping with each other, then that is known as lap joint. Two members to be connected. This is one member and this is another member. If two members to be connected are overlapped with each other, here some portions are overlapped, so that is named as lap joint. Board joint. Board joint means two members to be connected end to end. Here this is one member and this is another member. Yes. So this is another member. This is first member and this is second member. This is number 1. This is number 2. Here two members are connected end to end. But in case of overlapping or lap joint, two members must be overlapped with each other. This is the first member. This is second member. Here some overlapping portion is there. That's why that is named as lap joint. Okay. So in case of board joint, the members are connected end to end. Okay. Then we are providing one cover plate or two cover plate according to the requirement. We are providing one cover plate or two cover plates. See. But the first step is to connect the member end to end. We can provide one cover plate or two cover plate. See. Okay. The board joint is divided into four types: single cover, double cover, single bolt, double bolt. So if you are providing one bolt in one side, then this is named as single bolted single cover. Here one bolt in one side, yes or no? The connection, this is the connection point, end to end connection point. Then in one side we are providing one bolt, another side we are providing another bolt, yes or no? So that's why this is single bolted with single cover. Here double bolted with double cover. Okay. Another two board joints are there. See. This is single cover with double bolted, because in one side we are providing two bolts. That's why single cover, double bolted. Okay. And last one is double cover, double bolted. This is single cover, single bolted, double cover, single bolted. Then third one is, this is number 1, 2, and third one is double cover, double bolted. The next one, double cover, double bolted. This is the last one. End-to-end connection. Double cover. We have to provide two cover. One cover at the upper and lower cover, another cover at the lower end. Then double bolted. This is number 4. That is double cover with double bolts. Double bolts means in one side we are providing two number of bolts. That's why that is named as your double cover, double bolted board joint. Okay. So this is the side view and the top view. It's like this. Okay. Here. This is the top view I am drawing. The two corners we can see from the top. This is one. This is another one. So this connection point, end to end connection point, we can see from the top. That's why that is a dotted line. In the figure, that is a dotted line, and it is a solid line because this is the cover plate, upper cover plate. You can see the corner points of the cover plate from the top. Okay, this is bolt. So you can provide any number of bolts according to the design. Okay. So the center line is dotted and the outer line is solid, because from the top we can see the outer line or the center line or the end-to-end connection, and here two forces are acting, two tensile forces are acting. One is at the left end and another one is at the right end, because we are applying force at the center. That's why two tensile forces are acting. One is at the left end and another one is at the right end. Okay. So see the figure. See. So this is a dotted line, the end-to-end connection which you can see from the top, because this is the top view, and here these are the solid lines, that is the line of corner of cover plate, and two forces P, one is at the left and another one is at the right. See, pitch. Pitch is the distance between two consecutive bolt holes measured parallel to the direction of stress or measured horizontally. We are measuring pitch horizontally. This is the distance between two consecutive bolt holes. The distance between two consecutive bolt holes measured parallelly to the direction of stress. We are measuring the pitch horizontally. Okay? We are measuring the pitch horizontally. Just opposite of pitch is gauge. So if you are measuring the pitch horizontally, then we are measuring the gauge vertically. This is, the definition is same. We are measuring the distance between two consecutive bolt holes that is perpendicular to the direction of stress. If this is the direction of stress, then we are measuring perpendicularly or vertically. That's why gauge is just opposite of pitch. In case of pitch, we are measuring the distance horizontally, or that is parallel to the direction of stress, and in case of gauge we are measuring the distance vertically, that is perpendicular to the direction of stress. Okay. Then come to end distance and edge distance. So end distance is just opposite of edge distance and edge distance is just opposite of end distance. So let us discuss end distance. What is end distance? It is the distance from the center of a bolt hole to the adjacent edge measured parallel to the direction of stress. Means we are measuring it horizontally. From the center of a bolt hole to the adjacent edge measured parallel to the direction of stress, or horizontally, that is known as end distance. Just opposite of end distance is edge distance. Means from the center of a bolt hole to the adjacent edge measured perpendicular to the direction of stress. This is the direction of stress and we are measuring perpendicularly or vertically from the center of a bolt hole to the adjacent edge. and that is named as edge distance. Okay, so these are the technical terms, 4 important technical terms which we will use later during the calculation of problem or design of problem: pitch, gauge, end distance and edge distance. Pitch is the opposite of gauge and end distance is the opposite of edge distance. We are measuring 2 distances, one is parallel to the direction of stress, another one is perpendicular to the direction of stress. Okay. Let us read the definitions. Pitch, gauge. A row of rivets parallel to the direction of force is called a gauge line, and the normal distance between 2 adjacent gauge lines is called gauge distance. And edge distance, it is the distance at right angle to the direction of stress from the center of the bolt hole to the adjacent edge, and end distance, it is the distance in the direction of stress from the center of bolt hole to the end of the element. Okay, just opposite of edge distance. Next is a staggered pitch. So normal pitch and staggered pitch, what is the difference? The definition is same. We are measuring the distance, horizontal distance between 2 adjacent bolt holes horizontally or parallelly to the direction of stress. But in case of normal pitch, the arrangement of the bolt holes or bolts are in chain manner. Chain manner means in column manner or row manner. But in case of zigzag pitch, the bolt holes or bolts are arranged in zigzag manner or staggered manner. That's why the pitch in between is named as staggered pitch. So let's draw a figure for staggered pitch. So in case of normal pitch, 2 forces are acting. In case of normal pitch, in case of normal pitch, the arrangement is like this, in column manner or row manner. So we are measuring the pitch horizontally. It is the distance between 2 adjacent bolt holes measured parallel to the direction of stress or horizontally. So this is in chain manner or in horizontal manner or in row manner or in column manner. But in case of staggered pitch, the bolts are in zigzag manner. The bolts are in zigzag manner. That's why we are measuring the pitch inclinedly, and it is named as staggered pitch. It is named as staggered pitch. Okay. When the bolt arrangements are like chain manner, normal pitch, and when the bolt arrangement is like staggered or zigzag manner, then zigzag pitch. Always we are measuring the distance between 2 bolt holes, adjacent bolt holes parallel to the direction of stress or horizontally. Next is minimum pitch. So the distance between center of bolt holes should not be less than 2.5 times the nominal diameter of bolt. So this is the minimum pitch, which should not be less than 2.5 times the nominal diameter. So which we will use during the design of problem. So these are the different technical terms for simple connection, and in next slide we will read about the other connections, that is pin connection, welded connection and bolted connection. So thank you for today.